The new chapter for the syllabus is the chapter number 5, Introduction to Euclids Geometry. What is geometry? We have come across this word many a times in the branch of mathematics. Geometry. Let's see the root cause of the introduction, geometry. Geometry in the branch of maths is divided into geo plus metry. So geo in Greek generally refers to earth, and metry in Greek refers to measure. So the Greek names for geo is earth and metry is measure. The measure of earth is what is called geometry. But why did the mathematicians during those times did give importance to measuring earth is the biggest question out here. So in order to solve this issue, or in order to understand the reason behind, let's try to take the history back into existence. Going back to history, during those times, many Greeks had different plots or the farms which the farmers have divided. So every land was divided into different farms and then connected with the farm of the other farmer. And this is the farm of the other farmer. So they had many irregular shapes through which the farmers had their farms. So with this irregular different plots of the farms which the farmers had as the agricultural land, it was very difficult to recognize the boundaries, because during those times the river Nile with heavy floods used to flush out the boundaries. Usually the farmers used to keep the boundaries out with some indication and the marks. But when the floods arise, or when the river Nile, which is besides, overflows and the water flushes in to the agricultural fields, then the whole boundaries used to vanish. Imagine the farms or the plots which are irregular in shape, which had their boundaries marked, have washed away. How do we recognize the boundaries? How do we recognize the plots? So the farmers during those times had various issues regarding the exact geometrical structure of their respective farms. So this problem has been a serious issue during those times in historical facts. So this is the reason why many mathematicians have come into expecting some mathematical solution for this problem, and hence arised the topic geometry, the measure of earth, the measure of the lands, the measure of the plots. So once the plots are lost out through the washed, flooded out waters, then reconstructing the boundaries was done through the geometrical measurements. So the geometrical measurements were strictly the inventions of the topic of geometry dedicated to all the past mathematicians. Geometry, geo for earth, metry for measure. The study of earth or the measure of earth is called geometry, the topic which we're going to learn for today's session. Now, before we enter into the topic of geometry, it is very essential to investigate the historical facts which make us realize that different civilizations have approached in different manners for geometrical concepts. The Egyptians had their own way of measuring the volumes and the areas of various geometrical structures in their own manner. The Babylonians had their own way. The Chinese had their own way of measuring. The Indians had their own way. So every civilization has approached in a different manner, but ultimately the process coming out to be unique. So let's see all the civilizations combined to understand the geometrical concept of identifying the areas or the volumes of various different geometrical structures like the cone, the cylinder, the sphere, the pyramid, etc. Geometrical structures and their mathematical properties to be continued. Now let's see the Indian civilization which had its contribution in the world of understanding geometry and the geometrical structures. As in ancient days, the Harappan and Mohenjo-daro the Harappan and Mohenjo-daro civilization had been excavated through various investigations. It has been excavated that these civilizations were highly civilized or highly developed in the society during those times, and this was strictly dedicated to the geometry behind the civilization. So let's see how geometry played a vital role in uplifting the civilization into a higher or the highest society, in the respect of the highest society. In Mohenjo-daro, it was known that most of the roads were parallel to each other and they were exactly perpendicular. Even the concept of perpendicular or 90 degrees was used in construction of roads. So they had the roads which were well mannered and exactly constructed through the geometrical measurements was assumed. Even the houses which were constructed and the rooms which were built inside the house were said to be totally based on geometrical concept, as clearly evident through the historical facts behind the civilization explored through the excavation. So all these things, even the drainage system, the Harappan and Mohenjo-daro civilization is assumed to have the underground drainage system, which was not existing in any other different places there during those times. So the drainage system in the undergrounds was a startled investigation or a startled exploration from historical facts, which has been existing from those times. So this civilization was very much witnessed with geometrical importance and the constructions through the geometrical significance. The Sulba Sutras and many of the Vedic ancient scriptures, the manuscripts, are all clearly evident. Even the temples at which many symbols clearly indicate the importance of geometry, especially the Atharva Veda, which has the Sri Yantra, is interwoven with 9 isosceles triangles, which then lead to 42 subsidiary triangles. So many historical facts are witnessed with geometry and its importance in real life. History behind mathematics. History behind Indian mathematics. Before we enter into the introduction of geometry in its mathematical background, let's see how different mathematicians have understood geometry before they could apply geometry into the mathematics or into the real life. So Euclid's understanding of geometry. Let's see how Euclids have understood geometry in his period of time. Euclid's geometry. So Euclid's understanding of geometry is what we're going to discuss in today's session. In Euclid's understanding of geometry, we need to understand some basic concepts before we understand the geometry itself. So let's try to understand how Euclid has come into different basic properties before he could apply geometry in various real-life situations. For this, let me take an example of a cube for you to understand how Euclid's geometry can be applied or has been applied through each of the developed contents. Imagine I have a cube or a die. We all know that a die has 6 faces. So I take the example of a die in which each face of the die is called a surface. So Euclid has taken each face to be a surface, and each surface is nowhere related to the other surface. That means when I take this in this region, the other surface lies entirely in other space. So according to Euclid's geometry, every surface is in its own space, the other surface being in the other space. So each of the 6 surfaces will be in each of the different regions, is how we understand Euclid's geometry. And according to Euclid's geometry, every surface with the other surface is separated by a line or a curve. In this case, this surface being separated from this surface by this line, as can be clearly seen. So the surface 1 and the surface 2 are separated by a line or a curve. So in this case, a line separates the 2 surfaces. And further, Euclid's geometry understands that all the lines meet at a point. So here, this line, and the other line all meet at a unique point. So according to Euclid's geometry, 2 surfaces, any site which is in its own space is a surface of the die, and the 2 surfaces are in their own respective spaces but not in the same space, and both the surfaces are separated by a line or by a curve, and all the curves of the lines meet at one point, is how we understand a 3-dimensional or an object like a die, which is separated by first with a surface and then with a line and a point. All the surfaces make the line and all the lines make the point, is how we understand, with each of the surface making the line and each of the lines making the point, is how Euclid has come through the introduction of geometry. So all surfaces make a line or a curve. All lines or curves make a point, is how we understand. And we also understand that it is the surface which makes the line, and it is the lines which make the point. And this is how the transaction happens: surface to line and line to point. And surface is referred with 3-dimension and this refers to 2-dimension, and this refers to unique dimension, is how we understand. So before we understand this, let's try to understand on how the dimension is understood through the solid structure. Euclid's geometry connected with a rolling die. Now let's understand Euclid's geometry through a three-dimensional object, just like a dice. So let's take an object and understand the concept more stronger on how Euclid could understand geometry during his times. So as we have seen a dice, I assume this to be a three-dimensional dice in which I have 6 faces: face 1, face 2, face 3, face 4, and face 5, and face 6. So in this, each of the face is called a surface according to Euclid's geometry, as I refer with the surface. Now as I see that every surface is in its own space, that means this surface cannot be in this space, or this surface cannot be in this space. Each surface is in its own space, is how we understand the surface. So every surface is separated by spaces. And also, as I see the two surfaces, I can see that this surface and this surface is joined by a line or a curve, depends on the structure. Now every surface, say for example this and this, is separated by a line. This surface with this surface is separated by a line. So therefore, the two surfaces are separated by a line. All surfaces make a line. Now let's see how the lines make the point, or how the curves make the point. As I see here, the line 1 made by these two surfaces, and the line 2 made by these two, and the line 3 made by this and this surface, all the three lines, line 1, line 2, and line 3, all meet at this point. So this is the point where the three lines meet. So this point is made, indirectly is assumed to have been made by the lines of the solid structure. Say for example, I take this point which is made by this line, and this line. Therefore, the lines in the object make the point, is how we understand. So basically, the transaction goes that a solid, or the object itself, in this case being a box, makes the surface. The box is the initial making which makes each of the 6 surfaces. The solid makes the surface, and the surfaces make the lines or the curves, and the curves or the lines make the point. So the solid structure defines the surface, surfaces define the lines define the points, is how we understand the transaction series in the Euclid's understanding of geometry. Also, let's make the most important note in this case, that a solid is referred to as the three-dimensional structure. A surface is referred to two-dimensional structure, and a line is referred to a one-dimensional structure. A point is referred to a zero-dimensional or no-dimensional structure. The dimension of a solid is 3D, and as it goes here, it reduces by 1 unit, and as it goes here, it reduces by 1 unit, and as it goes here, it reduces by 1 unit. So the dimension of the specimen gets reduced by 1 unit as it gets reduced to a point. Solid 3-dimensional reduces to surface, which is 2, the line, which is 1, and then to the point, which is of 0 dimension or no dimension, is how we understand the concept of a solid structure to reducing to a point in Euclid's understanding of geometry. To be continued, we have the Euclid's understanding of geometry, which had the further properties which Euclid has referred in one of the most famous book called Elements. In the book 1 of Elements, there are totally 23 important points which are noted down by Euclid and his contribution to mathematics. Some of them are as follows, which are very important to understand as the basics before we enter into the concept of geometry. And the first property is that a point has no part. As you take a pen, it has a part because this is the piece of the pen. This is the piece of the marker pen. It has a part. This is the piece of the cap which has its own part. Is how we understand the content which has a part, but a point which I take, in this case, a point has no part. So my first property says a point has no part. It is itself a dot, represented by a dot. It doesn't have any dimension, and therefore a point has a 0 dimension. And this is the reason why we say a point has 0 dimension, no dimensions at all. The first Euclid's exploration is that a point has no part. Secondly, Euclid has come out with a line is a breadthless length. What do we mean by breadthless length? For example, I take a rectangle. This is the length and this is the breadth. Now, this cannot be a line. It is a rectangle, which is a surface. So this becomes a line when the breadth is 0. That is, it is breadthless. Mathematically, b is 0. So this length converges, and a line is a length which does not have breadth. This is a line because it has breadthless length. It has L, but it does not have B. This has L and this has B, so it is not a line. This is a line. According to Euclid, a line is a breadthless length. Now, the third exploration of Euclid in reference to geometry is that a line has the two ends of a line are points. This has been the great invention during those times where a line, imagine I take a line L, the end points of the line are points. Say I take P and Q. Euclid says the end points the ends of a line are points, is how Euclid has come to the conclusion. The ends of a line are points. In this case, being P and Q are the endpoints of the line. Euclid's geometry refers to a line whose endpoints are the points, always, for any line taken in the branch of mathematics. A line whose endpoints P and Q are points. The fourth point which Euclid has referred is about a straight line, defining a straight line. A straight line is the one which is evenly distributed with all the points on itself. The line which we are learning for today was one of the greatest and the efforted invention during those times. A straight line, according to Euclid, is defined to be the one which is evenly distributed with all the points on itself. That is, if I take the points, they must evenly distribute so that the line must exactly be passing through those points, is how I define the line. If the points are unevenly distributed, then the line cannot be passing through that. According to Euclid, this does not define a line, but this defines a line, because the one which is evenly distributed with all the points on itself is a line. Which is unevenly distributed with few of the points not on the line cannot be a line, cannot be a straight line, according to Euclid's geometry, is how we understand the property number 4. A straight line is the one which is evenly distributed with all the points on itself. Now, the fifth asserted principle of Euclid in its book of Elements is that a surface is the one which has length and breadth only. So, this refers to the point number 5, which says a surface is that which has length and breadth only. A surface is that which has length and breadth only. It doesn't have anything else other than length and breadth. For example, I take a rectangle. Rectangle is a surface which has length and breadth, but it does not have anything else other than length and breadth. So this is a surface. This is also a surface. This is a surface. This is a surface because it has length and breadth, is how we understand the surface, each surface of this box. Surface 1, surface 2, surface 3, surface 4, surface 5, and surface 6. 6 surfaces making a box. A surface which has length and breadth. A line which has length but does not have breadth. A line is a breadthless length, is how we understand the difference between the surface and the line. And the last property which we are going to study in understanding of Euclid's geometry is the 6th property, which says about the plane surface. According to Euclid, a plane surface is the surface which is evenly distributed and with straight lines taken on that to be itself. So, with the straight lines on itself is how we understand the plane surface. For example, I take this. This clearly is a plane surface because it is plane in our understanding. But according to Euclid, mathematically, a plane surface is the surface which is evenly distributed with no ups and downs, but plain and flat, and with straight lines on itself. If I take any two straight lines, they will be on the plane, but they will not move away from. All the complete straight line must lie on the plane surface. If it was a bulged surface, for example, I take I have a surface which is bulged out here, then a straight line does not completely lie here. It just cannot move. If I take a straight line, it moves outside of. As clearly seen, tangentially it moves out, but this straight line is not on itself. Since the straight line drawn on the surface of this particular diagram, the straight line drawn on the surface, on this surface, does not entirely lie on the surface. Therefore, according to Euclid, mathematically, this is not a plane surface. Therefore, this is not a plane surface. That's how we understand the concept. Plane surface is a surface which is flat, and mathematically any straight line lying on the surface must entirely lie on itself. Is how we understand the plane surface according to Euclid's geometry. So these are the different properties through which Euclid has come out with his investigations and his research, which has been reflected in the book of Elements. Euclid and his geometry contributed to the branch of mathematics.